just the properties first. Remember, when you have like bases, whether they are numbers or variables, when you are multiplying like bases, then you add their exponents. When you are dividing like bases, then you subtract their exponents. When you are taking a power to a power, you multiply those. And then some special ones. Anything to the 0 power is 1. Anything to the negative power is the same thing as doing the reciprocal of it. All right, so those are your properties there. When we have something like number 3, we are going to group everything together that is alike. So I'm going to group my numbers. I have 4 and 2. So I have 4 times 2. I'm going to group my y's. I have x cubed, x to the 4th. And I am going to group my, oh, that was x's. Then I'm going to group my y's, y squared, y cubed, y to the negative 2. All right. Then I'm just going to use my properties. When I'm multiplying numbers, I just multiply the numbers as they are. So I have 4, I don't know what, I went ahead and multiplied, by the way, in my head. Sorry about that. It's 4 times 2, which is going to give you 8. So I have 4 times 2. That's going to give me 8. For my x's, I'm going to add those exponents. So I have 3 and 4. And then I'm going to add these exponents, 2, 3, and negative 2. And that would be my answer. All right. For number 7, I'm going to take everything to that second power, which means I'm going to multiply these. If I had a number in front, it would be the number to the power. You're not multiplying the numbers. So if this were like 2x cubed y to the 0 power, I would have 2 squared x cubed squared y to the 0 power squared. So you can think of everything inside to that second power. All right, which means I'm going to multiply these. X to the 6, 0 times 2, y to the 0. Y to the 0 is just 1. It's just 1, the number 1. So 1 times anything is just that number. So I have x to the 6th as my answer. I chose a really simple division, and then I chose some more on the next page that include all of it. This is a little more intense here. Something like this, number 9. When I have division, I'm going to look at my numbers. Can I reduce 2 over 3? No. So that's going to stay 2 over 3. My x actually has nothing to combine with, but it can simplify. X to the 0 is just a 1. Well, 2 times 1, that is just 2. This y to the 4th has absolutely nothing it can simplify with, so it doesn't. It stays exactly the same. And so when I have something like that, don't overcomplicate it. Okay? Simplify what you can, leave alone what you can't simplify. All right, so when I have something like this, I am going to simplify inside my parentheses first before I start worrying about that negative 3 on the outside. So I am going to look at my v and say, can my v simplify with anything inside? It cannot. So it's going to stay a v. My u can simplify. All right? So on the inside, I have u over u, which means I subtract. I subtract the 2 minus the negative 1. 2 minus negative 1 is 3. That tells me that I have a u on top or bottom? Top to the 3rd power. The 2 cannot simplify with anything. It is going to stay on the bottom. By simplify, I mean all of the things inside the parentheses only have one variable. I don't have 2 of anything. I don't have 2 u's or 2 v's. I don't have 2 of anything. Okay? So now I'm going to look at raising everything to that negative 3rd power. So I'm going to say v to that negative 3rd power. U cubed to that negative 3rd power. and 2 to that negative third power. All right, let's see what that does. V to the negative 3, where is that going to go? It's going to go on the bottom to the third power. 3 times negative 3 is negative 9. So where is that U going to go? On the bottom to the ninth power. 2 to the negative third. All right. It's already in the bottom. So if it's already in the bottom as a negative, it actually jumps to the top, okay? Because it's like 1 over 1 over, which flips it. All right, so you can just think of it as always reciprocating. This is going to put it in the numerator to the third power. You can do 2 to the third power. What is 2 to the third power? Yeah, it's 2 times 2 times 2, which is 8. All right. So your negative just reciprocates it, which means if it's in the numerator, it reciprocates it to the denominator. If it's in the denominator, it reciprocates it to the numerator. I want to point out the difference here. Here we were combining 2 by using our subtraction. That always tells you positive on top, negative on bottom when you do that, okay? But if it's already in place with a negative, it's already in the numerator or already in the denominator position with a negative, it's going to flip it to the other one, okay? All right, so for 17, with something like this, so on the other one, everything was in parentheses to a power. So I'm going to simplify everything inside and then worry about the power. With this one, I have multiple stuff going on multiple places. And so what I'm going to do here is I'm going to try to simplify the numerator as much as possible and the denominator as much as possible. Then I'm going to go top to bottom. All right? So let's look at 17. The numerator is as simple as it can get. We have an m to the fourth. We have an n cubed. I cannot make that any more simple than it is. Denominator, however, I have a couple things going on. The first thing I'm going to deal with is that parentheses. So I am going to leave my numerator alone right now, and I am going to deal only with the denominator, okay? In the denominator, m to the negative first power to the third power, all right? So I'm going to say, well, I have an m to the negative 1 to the third power. I have an n to the negative 2 to the third power times n, m times n cubed, all right? So I'm just going to take it one step at a time. Leaving the numerator, still leaving that guy alone. That is still m to the fourth n cubed. Negative 1 times positive 3 gives me a negative 3. Negative 2 times positive 3 gives me a negative 6. And I have an m, that's to the first power, and n to the third power. All right? Now here I am going to still simplify my denominator. Anytime you have multiple of the same variable, you can keep going, right? And so now I'm going to use my property that says I need to add my exponents that have like bases. So again, I'm going to leave my numerator alone for right now. And I'm going to say negative 3 plus 1. What is negative 3 plus 1? Negative 2. I have negative 6 plus 3. That is negative 3. Now, for now, I have one m on top, one n on bottom, one m on bottom. You know, I have all of that going on. It's basically as simple as I can get before I start dealing top to bottom. All right? So now I'm going to deal top to bottom. All right, so now I'm going to deal top to bottom. So now I'm going to do the same thing I did up here, okay, with my m and n. So I'm going to take my m's, and I'm going to say I have m, and I'm going to subtract my 4 and my negative 2. 4 minus a negative 2. And I'm going to do the same thing with my n's. I have n to the 3 minus negative 3. What is 4 minus a negative 2? Positive 6. So where is that going to go? Top. So m to the 6th. What is 3 minus a negative 3? Also positive 6. Do I have anything left in the denominator? I do not. When there's nothing left in the denominator, you don't need one. If everything moves to the denominator and there's nothing left in the numerator, you must put a 1. There has to be a placeholder for the numerator. There doesn't have to be a place. Like if I have a 2, I don't have to write 2 over 1. It's understood. All right? But if I have 1/2, I can't just do that. That does not make sense, right? So when there's nothing left in the numerator, you have to put a 1. But if there's nothing left in the denominator, you are done. M to the 6th into the 6th is your final answer here. Now we get into polynomials. These are 4-point questions, so they're very easy 4-point questions, okay? The first question here is put it in standard form. Standard forms means highest to lowest exponent, all right? So I am literally, for standard form, I am literally going to say, what's my highest exponent? Well, that group has my highest exponent, so I'm going to list that group first. My next one, well, this is my next one, so I'm going to list that one. Remember, I am talking exponents, not coefficients. Highest exponent. And then my -3 obviously has my least. Once it's in standard form, all the other ones kind of fall into place. My leading coefficient. Well, now that it's in standard form, it's going to be my very first number. In this case, -7. Describe it. I need to name each polynomial by the number of terms. So if I'm naming it, I'm going to count 1, 2, 3 terms. That one actually has a special name. 3 terms is trinomial. And the degree is just that highest exponent group. All right. So in this case, 7 into the 5th is my highest exponent group, and my exponents there add up to 5. So I have all 4 questions answered. Standard form, leading coefficient, describe it by number of terms and by degree. And some of you wrote 5th degree trinomial. That's fine as long as all the information's there. So for addition is pretty simple. You're literally just combining like terms. All right. So when I do this, no matter which group it's in, I start with my highest degree. So that my answer's in standard form when I'm done, and I don't have to worry about rearranging it. So when I look across the entire group, both of them, I can see that 4 is my highest exponent. So I'm going to start with my x to the 4ths. I have x to the 4th plus x to the 4th. My next one is going to be my cubes. So I have 6x cubed plus a negative 5x cubed. And then I have my x's. I have a positive 8x plus a negative 8x. All right? Then I'm just going to simplify here. 1 plus 1 is going to give me 2x to the 4th. 6 plus negative 5 is going to give me 1x cubed. And a positive 8 and a negative 8 give me 0x, which I do not need to write because that is just 0. So this is my answer, 2x to the 4th plus x cubed. Some people prefer to change this to adding the opposite because they like the addition better, okay? So if you want to change this to an addition problem, you do that by leaving the first guy completely alone. You change it to plus, and then you change every single sign in here. Positive 8x becomes negative 8x squared. Negative 8x to the 4th becomes positive 8x to the 4th, and negative 5 becomes positive 5. And then you have a problem that is identical to your addition problem. You are welcome to do that if you prefer that method. If you prefer to always add, you can change it to addition, and then the second group, every single element changes signs, okay? Or you can do subtraction. It does not matter to me, whichever way is easiest for you. Again, I start with my highest exponent, and I underline them because I want to make sure that I have accounted for everything when I'm done. So I'm going to start with my 4th. I have 7x to the 4th minus, because this is minus, a negative 8x to the 4th. All right? My next one is x squared. Okay? I do not have an x squared in the first group. Okay? So if that's the case, I have just this minus sign and then my x squared in the second group. All right? Everybody see that? My next lowest exponent is x. I only have that plus 8x right there and nothing in the second group, so I don't have to subtract anything from it. And then my last one is a positive 7 minus a negative 5. All right, so pay attention to your positives and negatives here. The biggest mistake I see on quizzes would have been this guy right here. All right, because you look at it and you don't see anything to combine it with and you don't realize you're subtracting him. All right, once I have this, I am going to just combine my like terms. 7x minus a negative. What is that? It's plus a positive. So what do I have here? I have 15x to the 4th, okay? That minus 8x squared actually does not combine with anything. So it just stays minus 8x squared. The plus 8x also does not combine with anything, so I have plus 8x. And then I have 7 minus a negative 5. Once again, plus a positive 5. All right. So had I done it with the addition, you're going to do the same exact thing. 7x to the 4th, but now I'm adding 8x to the 4th. All right. I'm still going down, but you'll notice that this is now not combined with anything, a negative 8x squared. I have a positive 8x not combined with anything. And then I have a 7 now plus a 5. So if you change it to adding the opposite, you're going to get the same thing. You're going to get 7 plus 8, 15, negative 8x squared, positive 8x, 7 plus 5 is 12. So whether you do it with subtraction or whether you do adding the opposite of everything in the second group, you'll get the same answer there. All right, this is just foiling. It's repeated distribution here, okay? So we're going to start with that first term. We're going to say 3n times 3n. We're going to add to it 3n times negative 8. We're going to say 5 times 3n. And then we're going to say 5 times negative 8. Positives and negatives determine if you're adding or subtracting in between the terms, okay? 3n times 3n. 3 times 3 is 9, and when you multiply like bases, the exponent goes up. N to the first times n to the first is n to the second. Positive 3n, negative 8. What's that going to be, positive or negative? It's going to be negative. Positive times a positive. 15, positive, right. And then positive times a negative gives me a negative 40. I'm not done yet. These do have to be in standard form, okay? So I do want these in standard form. The only exception is if you have a special case and it's like plus minus, I'll let you leave those alone, like 1 minus 4x squared or something. But for these trinomials, they need to be in standard form, which means I do need to combine my like terms here. So I have 9n to the second power doesn't change. Negative 24 and positive 15 give me a negative 9. And then I have a minus 40. And so that is standard form for this guy. All right, standard form there. Questions on that one? The last page deals with special cases. And then special cases using numbers. All right? So you have two types of special cases. The first one is the square of something, whether it's the square of a positive or the square of a negative, it doesn't matter. It's still a square. If you don't remember this special case, you are welcome to write it out. It is identical. You don't change it to plus minus. Whatever it is, it repeats itself, okay? So if you don't remember the special case, you're free to foil it, as long as you remember that's what it means. The special case, however, is to square the first one. Double what happens when you multiply the first and the second one. And then square the last one. This one squared is going to be 9n squared. 2 times 3 times 3, that's going to give me 18n. And then 3 squared is going to give me 9. This middle term will follow the plus minus, because had that been a negative 3, it would have been 2, 3n, and negative 3 there, okay? This guy will always be positive because it's something squared, all right? So it will be always positive, but this plus or minus will follow that plus or minus. If you FOIL it, you will get the same answer, all right? Your second special case is like 54. Again, if you don't remember the special case, you're free to FOIL it. But when we start factoring, you're going to want to recognize these patterns. So you're free to FOIL this if you don't remember, but this is a pretty straightforward one. When it's plus minus, they're called conjugates. I take the first one and I square it. This one will always be subtraction in between it because it's going to be a positive times a negative. All right. And then just simplify. 4m squared, that is 16m squared. 6 squared is 36. And you are done. The plus minus will always cancel the middle term. So even if you FOIL it, you're going to get a positive and a negative of the same thing on this, in the center. All right? Questions on those special cases? And then numeric. If it looks like this, it's going to be 2 of the same exact thing multiplied. I want the closest to 10 pretty much. So I'm going to rewrite 61 as 60 plus 1 squared. That's 61 squared. And then I'm going to do my special case. I'm going to say, well, that's the first one squared plus 2 times what happens when I multiply the first and the second term plus the second term squared. All right. All right. Special case for that. So anytime it's a number squared, it's going to be the exact same thing, right? You don't have a plus minus for that one. This second one over here, this is when you're going to see plus minus. So they should both go to the same whole, okay? So the same power of or multiple of 10 is what you're looking for. These are both closest to 100, all right? One is going to be 100 minus something, one is going to be 100 plus something. This is your special case, a plus b, a minus b. So 96, I'm going to rewrite that as 100 minus 4, which means 104, I'm going to rewrite 100 plus 4. All right? That's what these should always look like. When it's two numbers multiplied, I'm always going to give you one that is closest to the same multiple of 10. All right? And then you're going to use the special case that we did above. The first one, squared, always minus the second one squared. All right? So if I square any power of 10, you're just going to double those zeros. So that's going to be 10,000. And then I'm going to subtract from 10,000, 16. So I'm going to get 9,984 as my answer there.